So today we are going to solve GFG problem of the day, that is implement try. So you know how autocomplete works while typing on Google, or how spell checks finds the closest word? The answer is tries. So try is a tree-like structure used for storing dynamic set of string, and it is highly effective in handling large data sets. So in this question we are supposed to implement try class, and we need to complete insert, search and is prefix function. So I will explain how try works. So initially you have given two words and we are supposed to do insertion operation in both the words. So let me start with the first word, that is A, and before that we need to create a root, and you should keep in mind that this root has no character associated with it, and initially it's pointing towards nothing. So we'll check the index of a, and it is 0, a minus a is 0, and we'll check child of 0, and it's nothing here, root is pointing nothing, so we'll put this as null, and if it is null, we are supposed to create a new try node with a, and we will put word end as 0 because it's not the end of the word, end is d, right? Then we'll check the next index, that is n, and its index is 40 minus 1, that is 13, and child of 13 is again null, so we'll create another try node with n, and word end is 0. Then again we'll jump to the next letter, that is d. D minus a is 3, 4 minus 1 is 3, and child of 3 is null. We'll again create new try node, that is d. Let's say d, don't mind it, and we'll put word end as 1. And once we got word end as 1, it means we have completed this letter. Then again we'll start with and we'll start with root, then we'll go to a, and it's already exists, so we will cover this thing only, we don't need to create another node. Then we'll jump to n, that is an, it already exists, so we'll go right here. Then again the next letter is t, we can't go here because it's d, we'll create something called t here. So this is how try works. We keep on adding and it keep on traversing and it do checks. So we will be going inside the try class, and let's go inside the private, and let's declare struct of try node, and let's go inside children and give the possibilities of all the letters, that is 26 a to z, and let's declare something bool is end, that is either 0 or 1, which we were declaring. And if we'll go inside the try node, we'll declare some of the values. So initially we will put is end as false, that is 0 in this case, and we'll go through each letter till the letter z, and we'll put the children value, that is index, and initially we'll put as null pointer, it's not pointing towards anything. I mean initially it's null pointer is as 0, right, unless we are creating a new node. And once you have done, we have declared all this. We'll declare try node root, and inside it, let me declare right here, and while implementing this try, we'll put root as new try node. So as we created a root here, so same way we'll create this first, and once we have created this, we'll do the insertion function. So let's say this node is root, and we'll go through each alphabet of the word, and we'll declare something as index also, as ch minus a, which we are doing here, right? A minus a, n minus a, it's like that. And after doing so, we'll check the condition. If node of children id x equal to null pointer, that is like this. If it is a null pointer, that particular index, then we will create a new try node. And after doing so, we'll switch to the next node so that we can perform the same operation on the next nodes. And if we reach the last letter of the word, we will declare this as true. And once we are done with this, we will go inside the search function, and so most of the code is same. I will just put a slight change. So till here everything is same, and if it is pointing towards the null pointer, if it is pointing towards a null pointer, we are not getting as 1. It means it has not reached till the end of the word, and we will return as false. So the condition is it shouldn't point towards a null pointer for search. And we will jump to the next node. My bad. Of idx. And if it is not pointing towards null pointer and we are traversing till the end, we will return as true. Or I will say return as node is end, because it's already bool, right? So it will return either true or false. So initially it was false and it will turn into true. And after doing this, we'll check is prefix. So before we are supposed to find till a and d, but in is prefix we can search till an. So if we are getting an inside this try whole structure, then we can return as true. So everything is same. This is just a slight change. At last, instead of returning this thing, we will return as true. So this is the corrected code if there was any syntax error. And if we discuss the time complexity of it, so it is O of n. We are moving to existing node or we are creating the new node. And if we talk about the space complexity, it is O n cross m, where n is number of characters of word and m is number of words in try. So basically we are creating new nodes, so it's O n cross m. So yeah, it's submitted. It passed all the test cases. Thank you.